Hello everyone, and this is the study guide for the polynomial tests. You have to excuse the printouts. My printer is not working very well. It's a brand new cartridge, and it's just printing very, very, very faintly. So let's go ahead and get started. On number one, it says for a polynomial function f, as x approaches negative infinity, y or f of x approaches positive infinity. So that tells us that this part right here is going to tell us as x gets smaller, y gets bigger. And as x approaches infinity, f of x approaches negative infinity. So as x gets bigger, y gets smaller. Which of the following must be true about f? So just based on what we know right here, because we're going up and down, this is an odd function. And because we're up this way and down this way, this would be an odd negative function. So we have an odd degree, and we have a negative leading coefficient. So let's see what it's asking us here. The degree of f is even. That's not true. The degree of f is even is not true. The degree of f odd, that is true. Leading coefficient is negative. That's true. And then just to make sure, degree is odd. Yes. Coefficient is positive. No. So it has to be C. Moving on. For the polynomial function g, as x approaches negative infinity, g approaches negative infinity. So as this goes down. Which of the following expressions could define g of x? Well, this is in behavior again, so it looks like this is just going down. We have two options here. Either it goes down like this and up like this, or it would go down this way and then down over here. So since we only have one end, we just have this end right here. We don't know about the other end here. So go up or down. This would be an odd, um, odd positive, and this would be an even negative. So let's see. Here, negative 5x minus 2x to the fourth. So this is our leading coefficient here. It's the highest power. This one is even and negative. This one is odd and positive. Well, I can't say, it's kind of faint. Looks maybe odd and positive, I hope. This one is this, so that's x to the fifth. That's going to be odd and negative. And this one is 2x to the fourth. That is even and positive. So the only one that is odd positive is B. Even negative. That's even negative. Sorry, I can't read this. Is that faint? 1 second. I'm going to go check something real quick to make sure I am reading these correctly. Okay, just wanted to go ahead and verify, and this actually should be a negative 2x out here in the front, so this should be an odd negative. So our answer here should be, the only one's even negative is A. The other ones don't match what we are given. Okay, number 3 is another in behavior one. This says, as the function f is given by this, what, well, let's make sure this is a negative 3 here, though I don't think it's going to matter. Which of the following correctly describes the in behavior of f? As the input values increase without bound. So input values are x. Increases means without bound means infinity. Increases means we are going to infinity. So it's asking us as x approaches infinity. So this is going to be an odd function. So we have an odd degree. And it is a There is a negative out here according to my laptop here. And so this is going to be a negative leading coefficient. So as x approaches infinity, f of x, for an odd negative, f of x should go down to negative infinity. So it looks like it's going to be b. Okay. If you didn't read the question carefully, you'll notice that both b and c describe this function. So the question is only asking about b, even though c would be, it does describe it. The question was not asking about it. Okay, that's the front page. Page 2. The graph of the polynomial function p of x is shown. Which of the following could define p of x? So let's see, what do we know? This says 1, 2 turning points, so we know it should be at least a third degree. We have a 0 at -3, so x equals -3. We have x equals 4 is another 0. And so it looks like what they kind of want us to do, so jot some stuff down. Looks like what they want to kind of do is factored form. So a factored form version of this could be x plus 3 times x minus 4. And so check down here. Gotta now check my answers against my very, very faint copy. So these two are both negative, and this one will be positive then, right? Okay. And these top two are positive, which means these bottom two are probably negative. There we go. So let's see here. X plus 3 times x minus 4. We have two of those that could be options. X plus 3 is right here and here, and x minus 4, so it could be either of these. So we've not that one, not that one. Then we can see that 4 has a multiplicity of 2, so it should be squared. So that looks like it's going to be b. Okay. The leading term of the polynomial function p is a sub n times x of n, x to the n. So this is just telling us that there is some number, and then we have x to some power. This right here just says it's the nth degree. Since it's the leading coefficient, this is just telling us our degree. Is a real number, and n is a positive integer. So, okay, the factors of p include these three right here. What is the least possible value of n? Since n is our degree, this is the smallest degree. So it's asking us what's the fewest number of zeros we must have. Well, I have 1, 2, 3. This is a real zero. Real zeros are fine. We can just keep them as is. These two, though, are complex zeros. So this first one, I should have its conjugate as well. So if if positive I is a 0, x plus I should be a 0. I should also be a 0. And then if 2 minus I, is it 2 minus I? 2 plus I. If 2 plus I is a 0, then x minus 2 minus I should also be a 0. So that means that should be all of them. So that means we should have at least five zeros. Complex numbers, complex zeros always come in pairs. The 0 and its conjugate would both be zeros. Oh, I did that completely off the paper. I'm sorry about that. So nth degree, or off the frame. Nth degree, real zeros, complex zeros, complex zeros. And so we have to change the sign on both of these to find the smallest degree. Okay, number 6. Number 6. A polynomial function p of x is equal to ax, that's a j, so axj plus bx k, where a and b are non-zero constants. Okay, j and k are non-negative integers. Which of the following conditions guarantees that p is an even function? So this is just saying both j and k need to be even for it to be an even function. Even functions slightly different than even degree. So we need to make sure j and k are both even. So looking at a here, option A says k is equal to 0. Well, if k is equal to 0, I could just say, well, j is equal to 1. That would not work. I can make it to where one of these is odd, so that wouldn't work. J is equal to 2k, and k is even. So k is even, that's good. And if j is equal to 2k, well, then j must be even also. So I cannot pick an odd number to show that this doesn't work. J plus k is even. Can I pick an odd number, so let's say 3, and add it to k, or add k to make an even number? 3 is 6, so that wouldn't work because I can make these odd. And then j times k is even. Well, can I pick an odd number, and can I pick another number to make this even? Yeah, I can pick 2. So that doesn't force them both to be even. Only B forces them all to be even. Okay, I'm going to cut this first video off right there, and I'm going to split this next page in the next video.